Hello and welcome to this video where I will show you how to implement thread-safe logging for your ESP32 projects. An ESP32 project frequently requires to save logging for future use via an API or web page. Since ESP32 projects can be multi-threaded, logging must be thread-safe. This video presents thread-safe logging code that you can use in your projects. Now let's take a look at what we'll be covering. In this video, we will look at the following. I'll describe what thread-safe logging is. We'll develop a strategy for thread-safe logging. We'll be reading from a log buffer and we'll be providing example usage of logging. Although logging is provided with ESP-IDF, it will only log to the serial output and the terminal. I wanted a means to log critical aspects of my application to memory and the access of log data from a status web page or query the logs via an API. In doing so, I had to consider that my logging system will be called from tasks that I define as well as events received from free RTOS. If I could ask you to leave a like on this video, and if you haven't already and you enjoy this channel, please hit that subscribe button. It goes a long way to helping this channel develop and really does mean a lot to me. Thread-safe logging means a logging system that can be used safely by multiple threads at the same time without causing data corruption, mixed log messages, or crashes. When several threads in a program try to write logs simultaneously, problems can occur if the logging mechanism isn't protected. Each log message must be written to the log atomically, that is, a single unit. Messages must not be mixed together. When a thread wants to write log data, it does so by putting the log data onto a queue. The queue is thread safe, so any messages are guaranteed not to be corrupted. A separate task reads the data from the queue and locks access to the log buffer by acquiring a mutex. This ensures that the thread blocks other threads, for example API calls, from accessing the log data concurrently. It also ensures that the log data are written to the log buffer atomically. The mutex also ensures that log reads can occur without log buffer corruption. On releasing the mutex, any waiting thread will run until it in turn acquires the mutex for exclusive access to the log data. My logging system had to be robust and not hold up producer threads and have a single point of log buffer synchronization. A log message, which occupies a single row in the buffer, comprises of a timestamp, a log level indicator, and the message itself. This diagram illustrates the design concept. There are several log data producers, including the main app itself, any tasks that are running, and events. Please note that the log messages produced by an event have an additional synchronization requirement. There is a method in the code for handling just this case. Log messages are placed onto the message queue. The message queue handles thread synchronization. A separate task reads the log messages from the queue and places them into a FIFO buffer. The oldest messages will be overwritten once the buffer is full. FIFO buffer synchronization in this diagram is the mutex used to synchronize access to the log buffer by consumer tasks. That is, the queue reader task and any external client consumer such as an API request or web page. The buffer comprises of an array of log messages. The parameters head and tail are used to manage read and write positions in the buffer. Head indicates the next read position and tail indicates the next write position. When the buffer is full, entries are overwritten from the beginning of the array. In a similar way to logging provided by ESP-IDF, I have defined some macros that can be used to put log messages onto the message queue. The macros define several log error levels. Macros suffixed with ISR are intended to be called from within event handlers. These examples illustrate how the macros are used in a task and event handler. This code snippet illustrates how to read log entries from within an event handler returning HTML to a browser. In this example, the log entries read are displayed as a table in the browser. Now let's take a look at the code. The file app.logs.c is the main source file for the thread-safe logging implementation. You will see that the code relies on the spin lock defined by port_mux_type. This is a specialized type of mutex. Methods xQsend and xQreceive handle the interaction with the message queue. The header file app.logs.h contains various macros and function definitions intended to be used by code external to the logging files. The header file logs.def.h contains definitions that are private to the logging source files. It includes the definitions of log buffer line entry and the FIFO buffer. Several enhancements can be made to this code depending on your specific usage scenario. I'll leave these as an exercise for you. Some ideas of enhancements are: add a tag to indicate the source of the error, the timestamp to be derived from a real-time clock, optimize memory usage with a dynamic message length, store logs in non-volatile memory, and use menu config to configure constants, for example, message size and number of buffer entries. Well, we're just about done with this project. I hope that you found this video useful and that it helped you understand how thread-safe logging works, and that you'll incorporate this solution into your next ESP32 project. I hope that you'll consider pressing the like button and subscribing to the channel. These actions really do help the channel develop and reach more ESP32 developers. I will be posting more videos on ESP32 development regularly. And if you'd like access to the source code and circuit designs for all of my projects, then why not become a channel Patreon member? Please see the link in the description. Thank you for watching, and bye for now.